Can our engineering education prepare graduates for the industry? We must find out if we want to move to a higher economy. How universities can better prepare graduates for the industry is a constant topic of debate. It will perhaps never end because the industry needs are changing rapidly, and the universities are constantly trying to adapt to such changes. Relevant to this debate is the recent introduction of outcome-based education (OB) in Bangladeshi universities offering engineering education. OB is a requirement for degree accreditation under the Washington Accord, an international agreement between bodies responsible for accrediting engineering degree programs. Along with satisfying the accreditation requirements, it is expected that the OB model of education would better equip the graduates to serve the industry. For all latest news, follow the Daily Star's Google News channel. OB is a pedagogical model that emphasizes the outcome of the educational process. While the traditional education system focuses on what is taught, OB places emphasis on what is learned. In other words, traditional education is time-based. The university allocates a certain amount of time for the students to study a topic of their interest and then moves on. The students' exam grades reflect their level of knowledge and the outcome of the course. The OB model is outcome-based, under which the universities must first fix what the students will learn at the end of their course. The whole learning process is then tailored to achieve that agreed learning outcome. The transformation from conventional to OB model is a paradigm shift that is complex and time-consuming. Will OB alone be adequate to ensure that the graduates offer the skill sets the industry needs, now and in the future? It's hard to say. Industry needs are changing at an ever-accelerating pace. On the other hand, a university needs at least 4 years to produce a graduate. It is a long enough time to make some skill sets obsolete and create demand for new ones. Not only that, the university will take some time to prepare a new curriculum or adopt a new pedagogical model. By the time the documentation, approval, and implementation processes are completed, it may become outdated, requiring another revision. Secondly, the industry will need so many different skill sets, some of which could be outside today's knowledge domain, that no one can learn them all. That means both the teachers and the students will have to be in a never-ending learning process. Given the existing gap between what students learn and what the industry needs, some universities are already considering new courses. These universities have formed industrial advisory panels (IAP), comprising representatives from academics and the industry. Such advisory panels are recommending new courses or changes in the teaching system as they deem appropriate. But this is proving quite a challenge, because everyone is proposing something, and coming to a consensus is not easy, and there are so many recommended new courses that the universities cannot accommodate them within the limited time and resources. Then came the requirement for OB, which is another challenge. However, the best part of OB is that it is pretty flexible on how teaching is delivered and the students learn. Remember, only the outcome is fixed while the inputs are variable. This is where the OB model gets interesting, because it allows us to explore the students' learning options. We all know what the famous Bengali writer Pramath Chaudhuri (1868–1946) said many years ago. A well-educated person is always a self-educated one. Excuse my inadequate translation from Bangla. Such wisdom is all the more applicable in today's world. It is so because, in a digitally connected world, the options for self-learning are practically unlimited. We can learn anything, anywhere, anytime, provided we have a connection to the internet. What's more, some of these options are entirely free of costs, such as Wikipedia or Khan Academy. But learning only from classrooms, books or internet-based resources is not adequate for engineering education. The students also need practical experience for a fuller understanding of their subject matter. It is here that internship and graduate training programs become relevant. In Bangladesh, until recently, only the medicine programs had internship requirements. Of late, business schools have also started such schemes in collaboration with the corporate houses. Graduate training programs, where a fresh graduate works under an experienced professional to earn experience, are also not very common in Bangladesh, although widely practiced in the developed countries. Only recently, some companies are offering internships or graduate training opportunities. We have another issue to address: how to meaningfully implement any internship or graduate training program. We must create a collaborative environment between academia and the industry based on a symbiotic relationship. For effective implementation of such programs, both the university and the employer must fulfill their respective responsibilities. The university must put its trust in the employer for the student's grooming and mentoring. The employer must also adhere to the standard adopted by the university for a student's assessment. Summarizing the points discussed above, we have three broad areas of action. First, we have to promote the culture of self-learning among the students. Should it not start right from the primary level? Second, we should implement internships and graduate training programs systematically and adequately. Third, the universities and the industry must work closely to create an environment of mutual trust. We cannot implement all these processes overnight, but let's at least start them. All we have to do is produce confident self-learner graduates. They can meet all industry requirements, present and future. Dr. Syed Ahmed is a consulting engineer and a freelance writer. He has long experience in infrastructure project implementation in Bangladesh and abroad.